There we go. So a few branch updates for you. So if any of you want to join our engaging and diverse committee, we are looking for volunteers. And although some of you might be aware that the nominations have closed, they will be opening back up again, really to help encourage people join the running of the committee. So we are looking for volunteers at all membership categories. You know, it's a very rewarding role to undertake. It will enhance your CPD volunteering experience, and will also enhance your CV as well. So if you want to find a little bit more about it, then you can basically email in, and I've got the email address coming up in a bit, or just drop us a line on our LinkedIn or Facebook page. But I do really encourage anybody who wants to get involved, then please do contact us and nominate yourself to join this committee, as it's very rewarding. Now, I'm sure you'll all be wanting to know what's happening with face-to-face meetings. And basically, what IOSH are going to be doing in the future is have a hybrid offering. So virtual meetings will still take place, but there will be face-to-face meets as well. So we'll probably end up having half face-to-face meets and half virtual presentations throughout the year. We're just trying to find out a little bit more information about that, and IOSH are going to basically communicate that out in the next couple of weeks. So as soon as we hear, we'll let everybody know as well, and then hopefully we'll be able to start getting back to face-to-face meetings and do that all-important networking, which I'm sure we're all missing. And the last thing I wanted to talk about is future topics. If you've got anything that you think, actually, we haven't presented on this, or I'm really interested in this sort of topic, or we haven't really touched upon these aspects in the competency framework, then please do let us know. Again, I'll be giving you information on how you can contact us later. So just to give you a little bit of an update on what's happening over the next couple of months. So on our April branch meeting at 10 AM, we've got drug and alcohol testing. So that will be a virtual event. So we will be sending out communication on how you can get involved with that one. And in May, we are going to aim to try and have our first live presentation. And we're aiming to do that at Bristol Aerospace. So with a bit of a tour there as well. So we're just talking to them and see how we can facilitate that. And we're also talking to IOSH to see whether that will be convenient and appropriate for us to conduct our first face-to-face meeting. So again, we'll let everybody know about that one. And in June, we've got a presentation from our very own Hayley, who is going to talk about IOSH future leaders. So a really interesting topic there. So how to stay in touch with us. I know this slide looks a little bit messy, but I've developed a few QR codes there for anybody who wants to kind of like scan their camera on their phone to be able to get in touch with us, because I know writing down long email addresses and long web addresses can be quite difficult. So please scan those QR codes, and then you'll have access to our email, our LinkedIn account, our Facebook and our Twitter. And if you wanted to get involved and find out what's happening on future IOSH webinars and Zoom meetings, not just for this branch but others, then we have a link there at the bottom as well. So on today's noise and dust presentation, for those of you who are filling out your CPD, basically we have got the following competency framework assets. So we're looking at risk management today, we're looking at health and safety law, we're looking at planning, working with others, communication and stakeholder engagement. And if you want to find a little bit more about the competency framework and what it all means, I've put a QR code there at the top right-hand side of the screen, so you can scan and go directly to that website. So That's enough of me. I'm going to introduce you now to Kevin, who is our guest speaker, and basically he will share his screen and take the presentation going forward. I just want to say thank you very much for everybody for logging in today. We value that everybody basically interacts with us, so please put your questions and chats in the chat box, and I'd like to say thank you very much for Kevin as well for joining us today. So over to you, Kevin.
Thank you, Nat. I think I need you to stop sharing, if that's okay. Thank you. Hopefully you can all see my screen. Can you see, is that right, Nat? Can you see that okay?
Yep, all good, thank you.
Might just see if I can close off my camera, but let's see how I'll do that now. Okay, let's see how we get on. Well, look, good morning, everybody, and thank you very much, Nat and Paul, for allowing me on today. So my name is Kevin Dupont. I'm from a company called the RVT Group. I've been with the company now for over 12 years, and my role has been around technical consultancy. And the business, which I'll speak a bit more detail on, is around protecting health in construction. As we know, there's been a lot over the years and years of focus on the safety side of health and safety, but we need to be looking at what we can be doing to protect our people and our clients, our neighbours, and whoever's affected by the type of construction work that we're carrying out. So protecting long-term health is really what RVT deliver as a business. And today I'm going to be talking through how we can support a contractor in today's environment working in construction, especially when that construction might be in a shared or occupied environment, like perhaps a hospital refurbishment or industry refurbishment, when there's that close interface with the client. But the sort of principles and control measures that should be employed in that really sensitive environment, in my mind, should be employed in general construction, because we've been wearing RPE and PPE for many years, protecting ourselves as in the operative. But what are we doing to protect the wider environment on site? And I think this is so important. And there's principles that can be put in place, especially at design stage or site setup stage, to ensure that we're not just protecting our operatives, but we're also protecting the wider environment, whether that wider environment is a hospital refurb or a brand new building where there's other trades in place. So hopefully that slide moved on. Can you confirm that slide moved on, Nat?
Yes, it has.
Fantastic, thank you. So RVT, just a little bit about RVT, because this is essentially a CPD presentation. It's not sales, although I'll be delighted to take any questions specifically around RVT and how we can support the end. But it's an educational piece about the type of products that are out there and the principles that perhaps we should be following when we're trying to control hazards that affect our health. And those hazards are essentially listed on the screen there. They're the type of control measures that we can put in place to manage hazards like dust, noise, and fumes. So airborne particulate in the form of dust and fume, but also exhaust fume using diesel plant inside. Ventilation, the importance of ventilation, whether that's just purely an oxygen supply to make a safe working environment, perhaps ventilation for reducing a buildup of fume or gas. Monitoring, environmental monitoring, or on-site monitoring. You know, we know how much dust we can be exposed to, and noise and fume. Unless we're monitoring these hazards, how do we know what sort of control measures are going to be effective, or are they being effective or not? So monitoring really forms a key part of how we can approach control of hazards like dust, fume, and noise and so on. Climate control, I'm going to briefly touch on that. It's less of a health and safety, but it's a particularly safe way of providing temporary heating and drying source in this, typically this time of year. Confined space equipment and environmental in the form of water treatment, which is more of the environmental side. But really today, I want to focus on that airborne particulate and noise. So we're probably all fully aware of the legal requirements on the 1974 Health and Safety at Work Act. Quite clearly identifies who's responsible for controlling of hazards affecting health. But as it says there, anybody who may be affected by the way the work is carried out. It goes back to what I said at the outset. How are we protecting the wider environment, whether that wider environment is a neighbour, a client, or just another operative on site? And you look at the cost regulations, the lengths that should be gone into when we are trying to control these hazards, putting systems in place that are adequate. And what does adequate mean? What might be adequate in one scenario might not be in another. If you worked in a hospital refurbishment project and you're working outside immunocompromised area of the hospital where patients are immunocompromised, you know, what is adequate then would be far greater than perhaps in a situation where somebody was perhaps fit and healthy. So that's why we talk about an ethical obligation that goes beyond the law. We know what the basics are. We know that essentially putting in a dust filter in a dusty environment is acceptable just about, but it's only really a starting point. What we need to do as an industry is look at every situation on its own merits. How much dust is there? What is the dust? We seem to view dust as just dust. It's nothing else. It's just one entity. It's just dust. We need to understand what that dust is. How much of it is there? Who's going to be affected by it? And that way we can put in tailored protection. It's that tailored protection, I think, is going to make the difference in protecting long-term health. Again, we all know the hierarchy of control, I'm sure. Elimination, substitution, engineering controls, administrative controls, PPE, in that order. Now, engineering controls very quickly is where RVT supply the equipment, but not before we've looked at ways of eliminating the problem. But if you can't eliminate it and you have to do the process that's causing the problem, can you do that process off-site in a controlled environment? If not, and you have to do it on site, can you still do it in a controlled environment on site? See, you go to site and you see people cutting up MDF or gypsum all over the site. We need to look at ways that we can control this better. Substitution, using a safer product, safer way of doing things, as we're well aware of. Admin controls, exposure limits, warning signs, or whatever it is, are they going to be applicable in the environment you're particularly working in? You know, you can't sort of put a limit on, well, you can, on a hospital refurb where there's immunocompromised patients there. They can't be exposed to anything. And then finally, PPE is the last resort. So we do need to, as an industry, look through these steps. But if you can't eliminate and substitute it, then engineering controls is what RVT can provide. So when we look at dust, as I said earlier, people just assume dust is dust, but they don't really understand the inhalable dust and the respirable dust, the difference between the two. You guys will be fully aware of this, I'm sure. But when we're talking about the respirable dust, the dust that you can't see, how can we effectively control it? Even the inhalable dust, the dust that you can see, we need to also be aware of not just protecting people's health, but protecting people's work, other trades work. I was on a site recently, and only working with gypsum, nobody else on site, but the electricians have been in. There's a lot of exposed electronics or electric componentry exposed to residual dust. So it's not just about protecting health, it's about protecting the wider environment, protecting other people's work as well. But when we're looking at respirable dust, invisible dust, as you can see on this slide here, it's invisible, just to make it absolutely clear. Human hair through the center of the screen there. Compare that in size to the PM10s in blue, it's going to be invisible. So how do we manage a hazard that is completely invisible? Now, what typically happens is a contractor would just use what is the good old air scrubber. They'll put a filter box in the corner, turning the air over, and eventually filtering out the dust. It's likely to have a HEPA filter in it, so it will take care of respirable dust and MDF and so on, but only over time. And this is the thing, the guy causing the problem causing the hazard, causing the dust, would have a really good face fit mask on. But what he's not aware of, the dust that he's creating could be invisible. Somebody else could walk into that zone thinking it's clean and breathing a lung full of respirable dust, silica dust or something like that. So we've got to come away from this idea of accepting that a dust box, a dust scrubber, a dust filter sat in the corner without any obvious LEV, local exhaust ventilation element to it. We've got to come away from that and look at a better way of controlling the environment. The way we can do this is to employ this methodology for effective health hazard control called the 3 Cs: capture, contain, and control. We all know what capture is. The vacuum, the LEV plugged into a sander, grinder, cutter, whatever it is picking up the dust at source and filtering it. But that's only the bare minimum. If you look at certain processes, the high velocity of cutting can be 180 miles an hour. The dust is just propelled into the environment. If it's respirable dust or any dust, it's not going to be captured. You're not going to capture it all through an on-soil extract. So rather than just relying on capture, let's look at ways that we can contain processes. So this is really going back to site setup stage, identifying the projects in terms of what material is going to be used. What overlap is there between different trades? Is there going to be a conflict? If there is, can we look at ways of certain trades working in one zone? It could be a pop-up tent. It could be a screened off area. It could be simply a nominated room. If you're going to cut up MDF, we'll cut up in one room so you can contain it, and that's the second C. And if you can do that, you can massively, effectively control it by simply working with air pressures, very much like an asbestos contractor would do. You might say that's elaborate, that's over the top, but it's not expensive in terms of the equipment you hire. It's just a bit more education, it's a bit more thought, a bit more planning, a bit more time set aside at setup stage, where trades are going to work in relation to other trades, so we can protect the wider environment. I do this every time I talk through all 3 Cs on that previous slide, but this is what this slide is talking about: capturing the hazard as it's created, contain it, work in a separate zone, and then control it working with negative pressure. Just a few examples of what that looks like. You've got a guy there drilling into a concrete column. So concrete, silica dust, invisible, respirable dust. He's got a capture hood as close to the noise source as reasonably practical. That's picking up the dust, it's filtering it through that dust master unit, which would have a HEPA filter in it to take out that respirable dust. Now, he might have to drill in all those columns there. The next question is it reasonably practical for him to certainly capture at the source? He can do that by moving that tool along, that extract along. But could he really use that second C of containment on every pillar, column he's drilling into? That would be deemed to be, in my mind, not reasonably practical to achieve that. But at least if he tries to get the capture 100%. Now, any type of capture is massively reduced. The performance of that capture is massively reduced if that capture hood is moved away. It doesn't have to be moved away a lot. The performance of that capture is going to reduce very, very quickly. So it's an educational piece here of understanding the invisible nature of the dust that's dangerous and using the capture to pick up the dust as it's created and filter it, not only protecting him, but protecting the wider environment. Now, I just wanted to share a case study, if you like, of a contractor, a tier 1 contractor working in the school. I should add, it's a brand new school. There's no students, there's no teachers, it's just a brand new school. But for whatever reason, they're working with cementitious board, so high silica content. And the contractor was concerned about this respirable dust spreading to the wider environment. They knew that the Makita, so I should probably mention the name there, but they knew that the M-class vac used as an LEV attached to the cutter was never going to capture all of the dust, this invisible dust. So instead of just relying on that first C of capture, they've contained it by building a purpose-built room, prepping this board. And then, in addition to that, to capture that residual spun-off dust They've got a capture hood at the end of the board, picking up that residual dust. And finally, they're putting that room under a negative pressure, because where that green box is pumping filtered air into the wider building site environment. So this is about protecting the wider environment. The guys in that room would have to have the RPE on, obviously, but it's about stopping that migration of that respirable dust into the wider environment. Probably notice there's quite a lot of dust on the floor there, but these systems are designed to capture the respirable dust. It's not so much about that inhalable large particulate. It's designed to capture and deal with the most dangerous type of dust, respirable dust. So if you are working in, that was like a brand new school, so that was completely standalone. If you are finding yourselves working in environments where you need to screen off from the wider environment, like on a hospital refurb or industry as well, using temporary hoarding systems that are sustainable in that they don't have to be cut, they fit from floor to ceiling and flexible adjustment. This enables a separate zone or space to be created to protect the client from dust and fume and potentially noise from a building site size. So you're creating this segregation area. You can then put it under a negative or possibly a positive pressure to protect against any migration of that invisible dust. So a simple to use, quick erect hoarding system. If you're somebody that works in live areas again, but you need to access a void space in a live area, a trolley type system with a tent on it that goes from floor to ceiling enables safe access to the void space under a negative pressure. So you go in there, you go up the steps into the void by moving the tiles, any dust that comes back down into your tent is completely filtered out and that tent's put under a negative pressure. And that enables you to even go into a live hospital ward and access that void space for maintenance purposes, perhaps, without any risk of contamination in the wider area. So critical situations like hospitals or perhaps even industry, pharmaceuticals and so on, it'd be ideal. So I'll just touch on the last couple of slides, negative pressure, and just for those that don't understand, I'm sure you'll do, but just basically in simple terms means extracting more air out of a space than can get back in easily. So that principle, taking air out, creates air to try and return. And that principle, returning air to that space, keeps the dust contained in the work zone. So if you are sharing your work site with a live hospital ward, then putting your work site under a negative pressure is a fail-safe way of stopping any invisible dust or any dust. And if you work in that environment, you might have to consider aspergillus and so on. How do you stop that spreading? Well, negative pressure is by far the simplest way to do that. And it's cost effective. It's not expensive. It's just a simple filter system set up in a certain configuration. And the filter systems that we use are an LEV in their own right, but simply set up a different way to create a negative pressure, namely extracting from within the work zone to outside the work zone, obviously filtering out any dust or fume before you do that, which obviously makes sense. You see the green arrows there, that's the makeup air returning into the work site and stopping the dust going against that airflow because of the negative pressure. Just all that makes sense. You might need to look at positive pressure systems, airlock tents like an asbestos contractor might do. Now you might say that's a bit over the top, but if you are in a sensitive environment, like the hospital I keep talking about, having an airlock over the doorway can stop any, can allow access from the clean side to the dirty side without any transfer of dust from one to the other. You may have areas on your building site that you need to protect, perhaps a room or a space that's been handed over, deep cleaned and so on. Or you might have, in this case, like an IT room or comms room. How do you protect that? Again, very simply, picking up the dusty air from the building site side, filtering it first, pumping purified air into the area you want to protect, and that will stop any dust or fume migrating into the areas that you need to keep protected. Airlock tents, as I've just touched on earlier. So over on the left here, if you imagine that this area here was a work where my cursor is a building site, and then this wall here is the partition wall between the building site and a live hospital ward, and you need to get from one to another. So you simply put this tent, which you can see on the right in the middle here, set up over the doorway. The green box is picking up dusty air, filtering it with a HEPA filter, and pressurizing that tent, blowing up like a balloon, if you like. So you would walk into that tent, you can imagine the air coming back at you, keeping the dust at bay, keeping the dust in the work side, and then you shut the door up behind you before you progress on into the live hospital ward. And that would stop any dust coming with you from A to B, if that makes sense. So a really simple, cost-effective way of protecting against any transfer of airborne particulates from one zone to another. We often use negative pressure, but some situations, the volume can be so vast, you need to put under negative pressure. You need a lot of fans, big fans, high pressure fans, a lot of filters to go along with that. Sometimes there's a much simpler solution by simply creating an airlock over a doorway. Sweeping, there's a lot of banning of the broom going on with good reason. Why would you want to sweep up something that's taken hours to settle? We talk about the respirable dust, it stays airborne, but it's so lightweight, it stays airborne for hours. So rather than sweeping, using M and H class vacuums is something that RVT can supply. We do actually have one now, has essentially a self-changing bag mechanism, because one of the biggest problems with vacuum is great till you come to change the bag. And invariably, they go and change the bag, and dust gets just chucked everywhere. So it has a self-sealing bag system. So that's the latest innovation on vacuums. But using vacuums rather than sweeping, is a no-brainer really, if you can. Dust suppression, damping down of dust. We do a range of dust suppression units, mainly for demolition contractors, sometimes used internally, but it's usually external. And these provide a fine mist, which is so important. So if you're trying to encapsulate, as in suppress, respirable dust, which is obviously microscopic, you need to use a mist or a fog size droplet to be able to capture around the microscopic nature of silica dust or respirable dust. It's no good anybody standing there with a hose pipe with large droplets or a watering can. It needs to be a fine droplet. It could just be a pump spray. It doesn't have mechanical means, but it's using fine mist is the way to deal with respirable dust. So moving on to fume control now. There's been a bit said recent years over welding fume, deemed to be carcinogenic across the board now, irrespective of what welding you're doing. But again, we can apply those 3 C's principle, because fume is obviously a particulate like dust. We can still look at ways you can capture it and contain any processes and controlling it using negative pressure. The only key difference is obviously dust. We can't just pick up at source and bend to atmosphere and just pump it out the window. But in a lot of situations, fume you can, depending on where it is. So the only key difference here between the fume and the dust is that you might not have to put a filter on the system. And you can often use increased ventilation to deal with the control element of dealing with fume. You could just perhaps dilute it to a safe limit or safe concentration, if you like, by just increasing airflow through a space. So portable welding fume extractors, LEV systems that are designed to be able to be carried around, so whether processes are being carried out, whether it's portable or whether it's mobile. And this is a situation actually in a train station refurbishment, Waterloo. And obviously creating fume. Guy there's got the air-fed mask on. It's about protecting the neighbours, it's about protecting the public, protecting the wider environment, not just from fume, but the potential setting off smoke alarms and so on. This had to be extracted from source and to atmosphere. The other thing that we often find is some contractors try and handle fume that potentially could be volatile, and they use the wrong type of fan for that, namely the actual fan, where the electric motor is internal to the airflow. So if we're handling anything that's potentially volatile, it's so important to use a centrifugal fan that you can see on the screen here. You just see where my cursor's going. You can see the motor on the centrifugal fan is external to the airflow. That makes sense. So using the centrifugal fan for anything that's potentially volatile is critical. Onto diesel exhaust. As we know, I was going to London now, it's hard enough to use diesel plant outside, never mind inside, using diesel machinery. The diesel exhaust is carcinogenic, as we know, but it's the solids, the soot, the carbon in diesel exhaust as opposed to the gases. So we can use that 3C principle of capturing the hazard, whether it's a filter attached to the exhaust pipe. We can contain the hazard by working with fresh air supplies, and then we can control it by potentially not only ventilating to dilute any gas buildup, but also extract any machinery-like static plant. So it could be a generator or piling rig that's perhaps had to be used inside. We can extract that source and vent it to atmosphere. And that's really what we're looking at here. You can see the particulate filters on the left and in the middle images attached to the machinery. And this would remove 98% of those solids that cause cancer. So it does essentially enable diesel plant to be used inside. Of course, they should be looking at a hierarchy of control on this. They should be looking at eliminating, which is probably not going to help them. But then they should be looking at substitution. Can we use electric is the obvious way forward there. If you can't, then there is a solution on the engineering controls with a particulate filter that's removing just about all of that dangerous substance. If it's static plant, you can see on the right there's a little generator used in the train station. And this is like an LEV extracting from the exhaust pipe and taken to atmosphere. On noise control, we know noise affects a lot of people, not just physically, with noise-induced hearing loss, tinnitus, and so on. It doesn't have to be loud noise either. It can be relatively quiet noise, but for long exposures can cause these physical impact. But it also has a psychological impact as well, not just if you've lost your hearing, but also the stress that being exposed to not necessarily loud noise, but nuisance noise for long periods of time. So again, we can look at capturing the hazard using the engineering control step with acoustic screens and barriers. It's not a case of just using the old sheets that you always see for years on site fence panels. There's purpose-built enclosures for specific applications now you can use. But containing the hazard by breaking the line of sight, which is where these enclosures really come into their own, and then controlling it by making sure that the barriers are used, whatever they are, actually absorb the noise. There's no point making a housing around a noise source that's of a hard surface, exacerbates the noise, and the resonance of that noise increases the dB rating. So using products like temporary acoustic barriers is so important to control noise, but done at source. There's no point surrounding a perimeter site with acoustics. It looks good, very expensive, and not that effective. Much better, like you can see this image here, a guy with a breaker. He's got the barrier as close to the noise source as possible, and he's above the line of sight. They're the two key elements of controlling noise. And that creates an acoustic shadow. So the impact of the noise for those receptors in that shadow has been massively reduced by simply setting up a barrier in the right configuration, if you like. Using the temporary barriers, acoustic barriers, which can be used internally, externally, but we do a couple of products that are designed for specific applications. We always try and find out what is the noise source. Is it high frequency or low frequency? Because that is so important to understand that when you determine what sort of control measure, as in what acoustic barriers you actually put in place, because they're not always suitable for both situations. And you could be, the contractor could actually be paying for something they don't need, essentially. But scaling it up and identifying particular hazards, in this case, an M&E contractor typically creates 110 decibels when they cold cut through a bit of pipe. And when they're working, when they're on site, an M&E contractor on site, there's often a lot of exposed hard surfaces, so the noise is reverberating around the space. So if we can get them to work in like a cutting station, as you can see there, that with perhaps a 3-meter exclusion zone can get 30 decibels off the 110. So it's taking it down to that lower actual level of 80 decibels. So it's making it safe for the wider environment. Now, if it didn't work in there, and you had an exclusion zone around from 110 down to 30, you're probably looking at 20, 30 meters of exclusion zone, which is not practical in most sites. So getting M&E contractors, dry liners, anybody cold cutting steel to work in an acoustic enclosure like that can make a huge difference. Other products for specific applications, street works and so on, chapter 8 barriers, little houses. The whole purpose of this is to identify the noise and deal with it at source, like any of these hazards. That is so important. Ventilation, increased ventilation, I touched on at the outset. Diluting gases, fumes, fresh air supply into confined space, using ways of capturing particular hazard in these environments to atmosphere, but also using fans under positive pressure to dilute and just provide air change. Could be positive or negative pressure, depending on what we're looking to do. But ultimately, if forcing in most cases, under positive pressure, that works best. Rather than in your confined space having some form of extracting out, better to put a fan on the outside, pumping in clean air to as far away from the outlet as possible to give wholesale air change in that confined or restricted, perhaps a better way to describe it, restricted space. This could be diluting gases, as I said. Because ultimately, if you've got extract in there, if you say you're doing a basement dig, you could be actively drawing out gases from the ground. So we'd always try and put in a positive pressure, as you can see in that image there. And we have a whole range of fans to do this. High pressure fans, low pressure fans, but designed to give air change and create a safe working environment. There may be situations where you need to use ventilation to protect, as we looked at earlier, the IT room, if you remember, and the positive pressure. Often in London, where I tend to spend a lot of time, the project office, the welfare, the kitchen, the canteen are all part of the building that's being knocked about, being worked on. So you've got this residual dust in the environment. How do we stop that entering into these areas that should be perfectly clean? Not just the kitchen and the canteen, but the project office. You've got a lot of IT in there as well, and you've got a lot of people there need to be protected. So simply picking up dusty air on the outside, filtering it first, pressurizing into that area will stop any of that migration of fume or dust. Monitoring, the importance of monitoring the hazard so we can determine, well, what do we need to do about it? So we can provide a range of environmental monitors for dust, noise and vibration, usually on an environmental level on a perimeter site, usually part of planning condition, but these could be used internally as well to ensure that there isn't a build-up of dust and we are keeping below the limits that we need to be working to. If you take noise, for example, and if we're not measuring noise, how loud do we know? How loud it is? Is it over 80 decibels or 85 decibels at upper actual level? And I think in a lot of situations it can be very quickly. I've just got a few. It's just off the Toolbox Talk website. There's a lot of stuff there. I won't go through them all, but down the bottom, angle grinding 110 decibels. We touched on that already. Look, even shoving hardcore generates 94 decibels. So simple processes in construction can go way beyond that 80 or 85 upper actual level. And I was on site recently, and this guy he's collecting those clamps for scaffolding clamps, and he's just chucking them into a stillage. I don't know if he liked to just practice his aim or why he was doing it this way. He's just picking them up, chucking them probably, I don't know, 3 or 4 yards or something like that. And the noise, I was happened to be on site doing some measuring, and the noise from that, and it was well over that limit. Just doing something, it was a ridiculous thing to be doing, I know. But there's a lot of processes that can cause noise-induced hearing loss because of the amount of time they're spent doing that. So monitoring, importance of monitoring, identifying the activities, managing it, understanding what those exposure limits are, and making sure when we mitigate it, we've taken those two elements into consideration. That way we can then determine what we need to do in terms of the actual control measures put in place. And the monitors there, you can see them on the right-hand side, 3 of them for environmental noise, vibration, and dust. But over on the left is a fairly new, it's not new now actually, it's a traffic light system, a visual aid. So people can see when they walk into a zone, say where the M&E contractors are working, they're cutting their steel, they can see exactly how loud it is. So if they go in there and it's amber, then it's over 80. They need to start managing their time. If it's red, it's over 85, mandatory hearing protection, as we know. So the purpose of this is just to make everybody on site aware how loud, you know, the guy chucking the stuff into the clamps into the stillage, he would have seen that straight off as being probably red. So he would have known that he's affecting his hearing in the long term if he continued. Just finally onto temporary heating and drying. Traditionally, or in the past, you used to use gas heaters, which put a lot of moisture into the building as you heat them. And you've got manual handling issues, you've got fume issues, you've got explosive issues. So ultimately, when you're trying to heat and dry a building, we need to raise the air temperature, obviously, and we need to have some moving air, and we need to have some sort of dehumidification system. They're the three elements to heating and drying a building. So instead of using a gas heater, using an indirect oil-fired heater. So these are external to the building, which makes them a lot safer. And all you're doing is pumping in clean, dry heat. So it's a safe way of heating and drying a building. And that's generally the reason why I started there. Do electric ones as well, and monitors as well for relative humidity to manage the actual relative humidity in the building. But usually the indirect oil-fired heater bypasses the need for any dehumidification because it's a dry source of heat. And it avoids the manual handling, and it avoids the explosive because it's outside the building, and it puts in dry source of heat. And it's also environmentally friendly with it, using hydro-treated vegetable oil. Okay, so that's brought me to an end. So in summary, as it says there, if we're serious about protecting the long-term health of our people in construction, we've got to be looking at hazards on their own merits. We've got to look at what we can be doing better at site setup stage as we're planning the site. What can we be doing to make sure that certain activities have their space, can be separate from wider environment, looking at every situation on its own merits, because one size doesn't fit all. Instead, look at the 3 C's principle. We know capture is a minimum, but is there ways that we can effectively contain any particularly dangerous processes, like working with MDF or cementitious board, for example, or particularly noisy processes? And then we can effectively control it with air chains, with negative or positive pressure, and always using the HEPA filter to deal with those type of respirable dusts. So thank you very much for your time. I really appreciate you allowing me on today, Nat and Paul. But if you do need any more information, I'll see if I can answer some questions now. But there's a lot of stuff on our website, including toolbox talks and best practice articles and white papers. So thank you very much. Over to you, Nat.
Lovely, excellent, Kevin, brilliant. I really enjoy presentations like this. So thank you very much. Have a slurp of your tea, and it just proves to me that I've been scribbling stuff down, and you're always learning all the time, which is why these presentations are fantastic. So I mean, brilliant. I mean, the whole process of capture, contain and control, great control measure, buzzwords there, and great to add on to any of our risk assessments, I'm sure, that we've got out there. And I've got a joinery workshop here at my offices, and I found really positively that the visual display sign works really well. So before anybody enters our joinery workshop, they can see straight away where our levels of noise are at and whether they need to wear their hearing protection or not, because people were always saying, well, do we wear it or do we not wear it? And kind of like, so that this visual display made it category, really clear, and I think really helps. So that's good. And I know from recently we've had the HSE come around to a number of contractor sites, and they are not very happy if they see brooms at all now. So it is all about using your hoovers on site. And again, in like my joinery workshop, we've not had a broom there for going on 20 years. So that's absolutely fantastic. So just ask a couple of questions. So Ian O'Donnell has basically said, you mentioned different acoustic barriers for high and low frequency. Can you provide some real world scenarios for examples?
Yeah, so there's 2 products essentially that we do for that. One's 50 mil thick, the other one's 15 mil thick. Now, if you're looking at high frequency, perhaps like a chop off saw, then the thinner 15 mil thick does a very, very good job, and it's significantly cheaper. Conversely, if you're doing low frequency noise, or you perhaps start trying to deal with a generator, which is low frequency, then paying for the 50 mil thick one is really good value. So yeah, it's just really understanding they're the two sort of scenarios I would typically use for high and low frequency. But there's a lot in between. You know, if you look at braking, that can be low frequency, but it can also be high frequency depending on what you're braking and so on. So it is quite variable. And there is a cost difference between the two products, but you don't necessarily always need to have the most expensive one to be effective.
Excellent, thank you. Great examples, great presentation.
Sorry, Ian, I missed that. Was it Ian?
Sorry, excellent, thanks. Great examples and great presentation, much appreciated.
Okay, thank you very much, Ian. Appreciate it.
Thank you. Right. I've had a question come through and say, what are there any industry campaigns out there that I should be aware about? So I'm thinking of the Breathe Really campaign, which is a great one on dusts. Are you aware of any others that anybody can find any more information about?
No, I'm not. The Breathe Freely one is the one that will come to my mind as well. We're running an event actually in London. It's sort of second week into April, I think, where we've got some guest speakers, and it's not so much respiratory health. It's called Action. We did one a couple of years ago, Action on Dust. We've got one now. It's Action on Site Health, so it's covering all areas. Sorry, it's a bit of digression. It's not quite what you're asking, but that's what I'm pretty much focused on at the moment.
That's all good. And somebody was asking about, do you have any more detail about the self-sealing bags and how they work in the vacuums?
Yeah, so this is a bit odd way to describe it, but the best way that I can describe it, if you've ever seen a sausage machine making sausages and how that seals off each sausage, that's essentially what it looks like. It has a cable tie at the bottom and you put it out, and I mean, it might be best if, we can certainly do a trial for anybody that's interested in seeing it, but ultimately you don't get anywhere near the dust. Sort of self-feeding, or you have to put it out yourself, but it self-seals is basically probably the best way to describe it, if that's okay.
Yeah, no, definitely brilliant. No, thank you very much. If anybody else has any questions, then raise your hand now, put it into the chat box. But I think, Kevin, that most of them have already been answered. I'm just clicking through now. I'd just like to say thank you very much to everybody who has already emailed me in about interest on joining the Bristol West Committee. That's absolutely brilliant. So I'll get back to you individually on that. Well, if that's all done, we'll basically say thank you very much to Kevin. Really informative presentation. Thank you very much. It will be available on our IOSH website, so if anybody wants to go and visit that there. Basically, if anybody wants to get in contact with you, then basically they can email through to the IOSH website, or I think your number was on the slide. Paul.
Yeah, can I just mention, obviously, we're going to send out a feedback survey. If everyone could just complete that for us, that'd be fantastic. Plus the links to the Bristol and West website and the video links where that will be made available will be within that email as well. So you'll get that directly to you following this meeting this morning. So thanks so much for that. Much appreciated.
Excellent. Right. So thank you very much for joining. We all appreciate it. Thank you again, Kevin. And we will see you again on the next one. Goodbye now.
Thank you.